Okay, guys, so before we exited on Friday, I asked you guys to do this and try to solve this for Wednesday. So before you watch the videos, make sure that you already tried this, at least attempted this. Okay, if you haven't, I would press pause first and then I would attempt this problem. Okay, so it says, question is asking how many grams of BaOH2 are precipitated from 14.5 grams of NaOH in the following reaction. So first we have to write, always remember where it says how many, after that, those two words, it's always going to be the units plus the compound that you have to finish with. So you are going to finish here, okay? Are precipitated from 14.5 grams of NaOH. And remember, you always start with wherever you have a number, unit, and a compound. That's the stuff that you start with, all right? And always make sure you have your chart next to you, like I have it right here in the screen, so you know what is your path that you're traveling. As you can see, you're going from grams to grams, meaning you're going to start in mass because you always start on the left, moles mass, and you're going to move all the way to mass again. So you're going to go from mass to moles, moles to moles, moles to mass. Again, you're going to go from mass to mole, mole to mole, mole to mass. Okay? So first, we're going to look at mass to moles. And we're going to write down what we're given first, which is 14.5 grams of NaOH. I'm sorry, I was going to write Ba. Let me erase that. Of NaOH. That's what I start with, right? Okay, and I'm using the fraction that's pointing down towards moles. So meaning I'm using the fraction at the bottom, which is 1 mole of NaOH over the molar mass of NaOH. Okay, so you're going to find the molar mass of NaOH, and the way you find it is in the periodic table. And yes, O and H are separate in this case, okay, because O and H are separate elements. So Na is 23, O is 16, H is 1.01. When we add all of these together, we should get 40.01, meaning the molar mass of 16 plus 23 plus 1.01 is 40.01 grams of NaOH. Okay, and this way we get rid of grams of NaOH. Now we go from mole to mole. Remember, mole to mole means moles at the top, moles at the bottom. All right, so we remember the compounds. The only thing that's different is the compounds. So the compound at the bottom is always the one that we start with. Compound at the top is always the one that we finish with. Okay, so the one that we start with, as you can see, from 14.5 NaOH is NaOH, so NaOH has to be at the bottom. The compound that we want to finish with, it says how many grams of BaOH2, so BaOH2 has to be at the top. Okay, and now the coefficients. Coefficient of BaOH2 is 1, coefficient of NaOH is 2, and then this way we get rid of moles of NaOH. And finally, we can move from mole to mass. So it's going to be, we're going to use the fraction that's pointing towards mass. So it's molar mass of BaOH2 over 1 mole of BaOH2. And remember, just like we did with the molar mass of NaOH, we have to find the molar mass of BaOH2. But this time, O has 2 and H has 2. Because they're in parentheses and a 2 is outside. The only one that only has 1 is Ba. So Ba is 137.33. O is 16, and we have 2, so it's 16 times 2. H is 1.01, and we have 2. So when we first want to do the multiplication, so 16 times 2 is 32. 1.01 times 2 is 2.02. So we're going to add those now together. 137.33 plus 32 plus 2.02 gives us 171.35. So it's going to be 171.35 grams of BaOH2. So we're going to get rid of moles of BaOH2. And now remember, we're going to multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom, multiply by the top, divide by the bottom. You're going to have your calculator. You're going to do 14.5 times 1 divided by 40.01 times 1 divided by 2 times 171.35 divided by 1. You're going to get 31.05 because the 9 makes the 4 round up grams of BaOH2. Okay, so what about gases? So as you guys know, in your sheet, you guys also have a gas conversion, meaning you also convert to gas. Just a reminder, gases are at standard temperature. At standard temperature, a gas is 1 atm, and at standard pressure, standard pressure is 1 atm, and then at standard temperature, we have 273 K. Now, this can also be abbreviated as STP. Again, STP just stands for 1 atm or 273 Kelvin. The volume of the gas. So no matter what, at STP, no matter what compound, 1 mole of any compound gas is 22.4 liters. Okay, so we're going to use this information to actually do stoichiometry with gases. So it says, if you need to react 1.5 grams of zinc completely, what volume of gas of H2 will be produced at STP? I want you to just follow along with me, and we are going to I'll let you do an example by yourselves. So first, obviously, remember when I said whatever the number is, the unit plus the compound, that's where you start. Okay, and then wherever you have the what volume or how many, that's where you finish. What volume of gas of H2? So volume of gas of H2, this is where we finish. And then another key word here is STP. What does that mean? So if we use our chart, okay, we are going to start in mass because we start in grams. We're going to move mass to mole like we always do. And then from mole, we're going to move to mole again. Now, where are we going to finish? It says volume of gas. As you can see, we have two volume. We have a volume of solution and we have a volume of gas. So we are going to finish, obviously, as this is volume of gas, we're going to finish at volume of gas. And again, volume of gas is used all the time for anything reading STP. Again, volume of gas is always used for anything reading STP. So we're going to go from mass to mole, mole to mole, mole to volume of gas. Again, mass to mole, mole to mole, mole to volume of gas. So we are going to do 1.5 grams of zinc. And we're moving down to mole. So again, it's going to be 1 mole of zinc over the molar mass of zinc. Okay, so if you remember, that means that we have to find the molar mass in the periodic table. So zinc is 65.39 grams. So we need a eraser. Okay. So we are going to do 65.39 grams of zinc. And this way we get rid of grams of zinc. And now we keep going. Now we're going to do mole to mole. Remember, mole to mole conversions are just where the unit that we want to finish with always goes at the top. The unit that we want to start with always goes at the bottom. We want to start with, we started with zinc, so that means zinc is going to be at the bottom. We want to finish with H2. H2 has to be at the top. And we're going to use the coefficient. So for H2, we don't have a coefficient, so that's a 1. For zinc, we also don't have a coefficient, so that's also a 1. All right. And finally, we're going to move from mole to volume. And we're going to use the fraction that's pointing towards volume. That means that we're going to use 22.4 liters of H2. Oh, and sorry, by the way, this is how we get rid of moles of zinc. And we have H2, 22.4 liters of H2 over 1 mole of H2. And this way we get rid of moles of H2, moles of H2. And that's it. Remember, multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. So use your calculator. We'll start 1.5 times 1 divided by 65.39 times 1 divided by 1 times 22.4 divided by 1. And we have finally 0.51 liters of H2. All right, guys, so what I want you guys to do is I want you guys to pause the video here, and I want you guys to attempt this problem. Read it carefully. Look at your cheat sheet, your island sheet, to see where am I going, where am I stopping. This should be a pretty easy problem. This is one of the first problems that we attempted. Okay, so again, pause the video. And if you have completed it, now I want you to press play, and let's read the problem. It says, if you are making 0.57 moles of H2O, how many moles of O2 are needed? So it says we are making, and so we have this, so this is what we start with. How many moles of O2? So remember, wherever it says how many, this is where we finish. So we are going to start with 0.57 moles of H2O. And let's look at our sheet. Okay, so meaning we start here. We always start, remember, in the far left one. And we want to finish in moles. So this is a simple mole-to-mole problem. These are the first problems that we did. So this is going to be moles to moles. All right, and remember, the unit that you start with are at the bottom. The unit that you finish with is at the top. Okay, so the unit that we start with was H2O, so that's going to be at the bottom. The unit that we want to finish is O2, so that's going to be at the top, and we just take in the coefficient. So O2 doesn't have a coefficient, so it gets a 1. H2O has a coefficient of 2, so it gets a 2. So this way we get rid of moles of H2O, and we calculate. Remember, it's always multiply by the top, divide by the bottom. So with your calculator, you're going to do 0.57 times 1 divided by 2. And you should get 0.2829 actually, not 28, because the 5 makes the 9 round up. And that's going to be moles of O2. So again, I want you to do the same thing here. Pause the video, read the problem, use your cheat sheet to see where you're starting, where you're finishing. So, if you need to precipitate 10.7 grams of BaOH2, this is where you start. How many grams of NaOH, this is where you finish, are needed, okay? You're going to start by writing what you start with, which is 10.7 grams of BaOH2. So, cheat sheet says I am starting in mass. Where I finish is mass again. So that means I'm going from mass to mole, mole to mole, mole to mass. Again, mass to mole, mole to mole, mole to mass. So first mass to mole. So that means that I need the 1 mole of BaOH2 over the molar mass of BaOH2. Okay, so you need to find the molar mass of BaOH2. So BaO2H2. Remember, if it's in parentheses, that means it has how many, whatever numbers outside the parentheses. So Ba, we have 1, which is 137.33. O, we have 2, so it's 16 times 2. H, we have 2, so it's 1.01 times 2. 16 times 2 is 32. 1.01 times 2 is 2.02. All right, and we add everything together. So it would be 137.33 plus 32 plus 2.02. That gives us 171.35. So that molar mass is 171.35 grams of BaOH2. This way we get rid of grams of BaOH2. Now, we are going from mole to mole. Remember, when we go from mole to mole, it's mole at the top, mole at the bottom. The only thing that changes is the compound. The compound that we start with goes at the bottom. The compound that we finish with goes at the top. So NaOH is what we finish with, so that goes at the top. Let's look at our coefficients. NaOH has a coefficient of 2. BaOH2 has a coefficient of 1, so that way we get rid of moles of BaOH2. Now finally we can move to molar mass. So we're going to use the top one, meaning molar mass of NaOH over 1 mole of NaOH. Okay, so now we calculate NaO and H. Na is 23, O is 16, H is 1.01. If you remember, I told you 23 plus 16 plus 1.01 gives you 40.01. And that's grams of NaOH. This way we get rid of moles of NaOH, we get rid of moles of NaOH. Again, similar, multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. Use your calculator. You do 10.7 times 1 divided by 171.35 times 2 divided by 1 times 40.01 divided by 1. And we get 4.99, or you guys can just simply round to 5.0 grams of NaOH. One more time, guys. Also pause the video at this point, please. Read this problem. See if you can figure it out. Where am I starting? Where am I going? Okay. So it says, how many moles of AgNO3, this is where I'm finishing, because they're asking me how many, are needed to react with 10.7 grams of CaCl2. This is where I'm starting. Okay. So we're going to write what we start with. We are starting with 10.7 grams of CaCl2. Let's look at our chart. Okay, I'm starting in mass. It says I will need to move to moles. So mass to moles. So you might think, am I just moving from mass to moles? Well, we want moles of AgNO3. We don't want moles of CaCl2, which means that this is actually a two-step problem. We are moving from mass to mole, mole to mole. Again, this is a two-step problem. Mass to mole and mole to mole. How come we have to move from mole to mole? Because we need to change compounds. So let me show you. So we're going to go from mass to mole, meaning we are going from 1 mole over the molar mass of CaCl2. This is the mass, this is the mole of CaCl2, because we can't switch compounds yet. The only time we can switch compounds is when we're using coefficients. We're not using coefficients yet. So we need to calculate the molar mass of Ca and 2 Cl's. Ca is 40.08. Cl is 35.45 times 2. Okay, so if we do 35.45 times 2, we get 70.90 plus 40.08. That gives us 110.98. 0.98 grams of CaCl2. Okay, now this way we get rid of grams, we get rid of grams. So look at the units at the top. We have moles of CaCl2. We don't want moles of CaCl2. We want moles of AgNO3. So here, this is where we can switch the compounds. If you remember the compound that you start with goes at the bottom. the compound that you want to finish with goes at the top. And now we can use coefficients. So AgNO3 has a coefficient of 2. CaCl2 has a coefficient of 1. All right, and this way we can get rid of moles of CaCl2, and we would finally have the unit that we want. Multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. Use your calculator. Oops, I do not want this. I want it right next to it. Sorry. There we go. So we have 10.7 times 1 divided by 110.98 times 2 divided by 1. And we finally get our answer, which is 0.19 moles. It's 9, by the way, moles of AgNO3. This is the final problem that we're going to do today. So if you guys could please pause your video again and attempt this problem for me. So, question is asking, if you produce 15.4 liters of H2 at STP, how many grams of ZnCl2 is also produced? So remember, wherever you have your number, unit, and compound, that's where you start with. Wherever it says how many, this is where you finish. So in this case, we are starting with 15.4 liters of H2. So let's use our chart. Always have your chart next to you because it actually helps you a lot. So we are actually starting this time over here in volume of gas, because we have liters of H2 at STP, meaning we're going to use the fraction at the bottom. Okay, so the fraction at the bottom reads 1 mole of H2 over 22.4 liters of H2. This is how we get rid of liters. This is how we get rid of liters. Okay, now we're at mole. And now we're going to do a simple mole to mole conversion. Remember, moles to moles means mole at the top, mole at the bottom. The mole that you start with, which is H2, goes at the bottom. The mole that you want to finish with, which is ZnCl2, goes at the top. And you're using coefficients. H2 doesn't have a coefficient, so it's a coefficient of 1. ZnCl2 doesn't have a coefficient either, so it's also a coefficient of 1. And now you can move from mole to mass. Why do we finish in mass? Because we have grams. Okay, we are going to move up, so it's molar mass over 1 mole. So it's the molar mass of ZnCl2 over 1 mole of ZnCl2. Zn is 65.39. Cl2 is 35.45 times 2. 35.45 times 2 is 70.90. We added to 65.39. That's 136.29. grams of ZnCl2. Okay, and this is how we get rid of moles of H2O, moles of H2O. This is how we get rid of moles of ZnCl2, moles of ZnCl2, and we finally have our final answer in the unit that we want. Reminder, it's always multiply by the top, divide by the bottom, multiply by the top, divide by the bottom. So it's 15.4 times 1 divided by 22.4 times 1 divided by 1 times 136.29 divided by 1. We get 93.699, so it will be 93.70 grams of ZnCl2. So this is where we're going to pause, and then when we come back on next Monday, we will pick up after this problem. Okay, so again, attempt all of these problems, please, to see how you're doing, how you do. Remember, 3-step problems are the maximum. After, on Monday, we will start with limiting reactants.